Welcome back to the fourth installment of the UCP Africa ScanIT Training video series. In this video, we'll be discussing the various projections ScanIT can generate and how these various projections can assist you and your geological team in understanding, visualizing, and interpreting your data. Following from the previous videos, we will jump straight into a borehole which has completed both structural and geological logging, where we can focus on the various ScanIT projections. Please take note that the StereoNet and Orthographic projections will offer little to no benefit should you be logging core which has not been orientated. Here we can see our borehole was created with the default inclination and azimuth of -0.1 and 90 degrees respectively. We can see from the pop-up orthographic projection that our features and borehole are being plotted correctly at this time. So let's quickly view our data in the various ScanIT projections, simply for us to get an idea of the potential real space orientation of our structural and lithological information. First, let's take a quick look at the current data on our StereoNets. And now, in the three-dimensional orthographic projection. Using these tools, we at UCP Africa believe that our geological clients can potentially log their core while the hole is still being drilled, and long before any survey information is available. As we know, survey data is normally generated once the drilling has been completed. However, using ScanIT, the geological team can potentially still QA/QC their data while they await this vital information. So let's quickly import a survey into ScanIT. Using the export function, we export just the survey page. Then we simply copy and paste the survey data as it has been received from the tooling into the spreadsheet, save it, and bring it back into ScanIT. Once completed, we can now see the survey information inside of ScanIT and that the program has automatically updated every recorded feature's dip and dip direction accordingly. Getting back into it, let's take a deep dive into the UCP Africa's three-dimensional orthographic projection. We believe that this view of your data will help you and your team in fully understanding the real space orientation of your structural and lithological data. We open this view by clicking Projections from the tab and then Orthographic from the drop-down. We will be presented with a black screen with the orthographic view options displayed on the right-hand side of the screen. Using these options, we can select to display a white or black background, type in a start and end depth should you wish to access a specific section of your borehole, and also choose if you'd like a polar or a three-dimensional grid in the focal point of the screen, or neither. For our example, let's use the polar display. Below the orthographic display options, we can see a list of our captured structural and primary lithological features. We can select some features of interest by clicking on the slide bar on the right-hand side of each feature. By clicking the slide bar in line with the headings, we'll turn on all features. We can immediately see that planar features are displayed as a square plane, with line indicators highlighting the strike and dip of each feature. We can also see that primary lithological units are displayed as discs, and that they also change the color of the borehole itself to the primary lithological unit color. This is a quick and easy way for you to visualize how your geology changes as we proceed downhole. We have incorporated intuitive controls into the orthographic projection module. Use your directional arrows to pan up and down the borehole, scroll function on your mouse to zoom in and out, and then by clicking and dragging to rotate around your data. You can even double-click to reset the display to the plan view at any time. Each feature's display can be increased and its color amended. By clicking the respective feature name, you will locate an opacity slide bar to set the color's opacity and an input screen where you can manually input how large you would like to view the feature in the orthographic projection. By clicking apply, sets the new feature size. So, quicker and easier than ever before, geological teams can quickly inspect their borehole's information and obtain a real space, real underground orientation of all the logged features in their borehole. ScanIT has the ability to export this orthographic view as a DXF file. We can simply do this by clicking the Export to DXF button located above the feature list. We can then close the orthographic view and return to the ScanIT user interface by clicking the Close tab at the top right of the screen. Now let's view our data sets on a StereoNet plot. We can open the UCP Africa StereoNet by clicking the Projections tab and selecting StereoNet from the drop-down. Similarly to the display of the orthographic projection, the StereoNet program contains display information on the top right of the screen. Here we can select a variety of stereographic projections from equal angle through to polar projections. Below this, we can input start and end depths should you have a region of special interest in your borehole. Below that, we can see a checkbox to hide or display your borehole survey information on the StereoNet itself. Here you can see the borehole as consecutive black crosses as the inclination and azimuth changes as the survey data proceeds downhole. Then below our borehole display button, we can see all the recorded features in the borehole. At the top right, we can see 5 icons. We can hover our mouse over these icons to get their respective information. So starting from left to right, we have display poles, then display great circles of each pole. Next to that is the ScanIT calculated vector mean for all poles recorded. Then followed by contouring, and finally a filter button which removes any features recorded in between two core orientation discontinuities such as core breaks or core loss zones. So for our example, let us have a look at join sets 1 and 3 and how they may interact underground. We select their poles and their vector means. We then see a small triangle which plots at the calculated mean of the poles logged. By clicking this, we can see the calculated mean and standard deviation for each feature type. Should you have 2 vector means displayed, ScanIT will automatically calculate the plunge and trend of the line of intersection of the 2 selected features. We can quickly change the projection to display the polar StereoNet by clicking the StereoNet option button and selecting polar from the drop-down menu. In our example, we can see a pole which seems to lie far outside of our mean and standard deviation of our feature. A unique aspect of ScanIT StereoNet program is that it allows the user to either inspect the log feature on the core tray photograph or simply remove the plot from the dataset by deleting the plot here in the StereoNet. Of course, ScanIT will automatically recalculate your standard deviation and mean for your feature should any plots be deleted. We can continue to select each feature's contours and even filter the data to remove any features recorded which lie between 2 core orientation discontinuities. This allows our geological clients to observe a higher level of confidence in their structural data and how specific features may be interacting in their geological environment. UCP Africa's Stereographic module is a very powerful interactive program that allows the evaluation and editing of structural data immediately at the time the borehole is being logged, or at any time during the logging procedure. Please revert to the full user manual for more clarity as to how to correct surveys, clean data, and learn more about the various algorithms UCP Africa have incorporated into the Stereographic module. We can now exit the StereoNet module and return back to the ScanIT user interface, where we can move on to the next handy projection, ScanIT Composite Image. We open this view by selecting Projections from the tab and Composite from the drop-down. This projection will once again display a black screen similarly to previous models. The user can input the various selections on the top right of the screen by selecting and choosing depths they wish to be displayed and even the desired text size for the displayed feature information. By clicking Apply, ScanIT will generate a stitched image of your borehole. We can now select which features we'd like to be displayed by using the selector sliders on the right-hand side of the module. Similarly to our other modules, selecting the slider next to the feature headings will turn on all features related to that heading. We can now view our borehole and its logged information in the projected image. We can see our core with a graduated rule along the left-hand side showing 10 cm increments. On the right of the core is the lithological unit color for this specific rock type logged. We can now scroll up and down our borehole using our directional arrows and zoom in using our mouse scroll function to inspect and view our borehole's information as we move up or down the borehole. This can be a beneficial document to attach to digital reports or even share with your colleagues. We can export this information as either a PNG or PDF file format by selecting each option from the right-hand side of the module. We can then locate and open our PDF to view our borehole with its respective information displayed alongside the core on neat A4 pages, ready to be shared with your team or attached into your digital reports. Thank you for joining us on this training video, and remember, we can always refer to the written ScanIT user manual or ask a UCP Africa representative for more assistance. Join us again in the next installment of the ScanIT video training series, where we will be discussing the ScanIT exported data.